In this video, we're going to estimate and measure the area of two-dimensional figures. Area is the amount of square units that fit inside a two-dimensional figure. The equations that you use to find the area depend or change based on the figure that you're finding the area of. Let's first start with the triangle. This question says to estimate and to find the area. When you find area, you're finding how many square units fit in the inside of a figure. We can estimate by counting how many square units we see. I see 1, 2, 3, 4, 5, 6 whole squares. These two make 7, these two make about 8, and these two make about 9. So we can say the area is about 9 square units. Now let's find the actual area. The equation to find the area of a triangle is 1/2 base times height. Your base and height must make this right angle. The base and the height are the two sides that are connected to that right angle. Let's count the length of the base. It's 1, 2, 3, 4, 5, 6 units. And our height is 1, 2, 3 units. We can take 6 times 3 first. That's 18. Then we can take half of 18. That's 9. So the actual area is 9 square units. On this example, our actual and our estimation were the same. Let's go through another example together. This is a parallelogram, and we need to estimate and find the area of this parallelogram. Let's start with our estimation of our area. Remember, area is how many square units fit in the inside. So let's count how many whole square units we have. We have 1, 2, 3, 4, 5, 6, 7, 8 whole square units. This piece and this piece each look like half. So we can say that's about 1, making 9. And this piece and this piece look like they're about half, making another 1, so about 10. Using estimation, we can estimate that our area is about 10 units squared. Now let's find our actual. To find the actual, we need to take length times width. We know our length is along the bottom, and that's going to be equal to 1, 2, 3, 4, 5 units. Since our length and width have to make a right angle, we can make a right angle by going straight up from the length to the other side that is parallel. That red line is our width, and it's 1, 2 units long. So our area is going to be 5 times 2, or 10. So our actual area is 10 units squared. This matched our estimation of 10 units squared. Let's go through one final example together. This says to estimate and find the area of the following figure, which happens to be a circle. Let's start with our estimation. I count 1, 2, 3, 4 whole squares. We have several that are really close to being whole squares. Let's go ahead and round those up. So we can say this one, this one, this one, and this one are also close, making 8 squares. These two look like they might make a whole square, so that makes 9. These two look like they make a whole square, making 10. These two look like they make a whole square, making 11. And these two look like they make a whole square, making 12. So we can say that our area is about 12 square units. Now let's find our actual. To find the area of a circle, we take pi times the radius squared. In our equation, we have pi. Pi is an irrational number, and it goes on forever with no repeating. We can use the rounded version of pi, which is 3.14. The radius is a distance from the center of the circle to the outside edge. Our radius on this circle is 2. 2 times 2 is 4. So we have 3.14 times 4. 4 times 4 is 16. 4 times 1 is 4 plus 1 is 5. And 4 times 3 is 12. So our area is 12.56 units squared. Now this isn't exact because 3.14 isn't pi exactly, but it's a very close answer. So our estimation was 12 units squared, and our actual was 12.56 units squared. Our estimation and our actual were very close.